like to move on to the discussion part. And then if the other speakers are also still available, please turn on your their cameras and microphones so that we can start the discussions. And I would like to share again my slide to point out the two items that I'd like to mainly discuss. So while listening to the other speakers' talk, I found that these 2 points are really important and worthwhile to discuss in these sessions. The first one is the gap between the embodied intelligence and the computational intelligence. For example, the Hughen nicely illustrated or highlighted the differences between she said mechanical intelligence and the computational intelligence. Both have the advantages and disadvantages or challenges. And then the question is how we can really integrate these two types of the intelligence. Also, the Amy showed a very nice picture showing the layered intelligence. If I remember correctly, it includes the artificial intelligence, embodied intelligence, morphological intelligence, physical intelligence, and then mechanical intelligence. There are so many different types of intelligence, and everyone understands that of course, the body is very important for the emergence of intelligence, but also the computational part would be also very important for further advances or acquiring the higher level of intelligence. And then the question is where we can really meet researchers from the computer science or computational intelligence, and also the researchers from the embodied intelligence. I think both really understand the different types of intelligence. But still, I think the challenge is that it's not so easy to integrate these two directions, the computational side and the embodied side. So do you have any idea how you can, for example, in your research, how you can integrate the computational, the architecture? Like, for example, the recent, these days we have like a nice deep neural network model or large language models, which can be also integrated in the embodied intelligence research, for example. Or the embodied research can also contribute to the further advancement of the deep learning, for example. So are you already challenging these kind of issues? Or what do you expect to integrate to these two directions? Shuhei, would you like to start?
The definition of computational intelligence is a bit broad, so maybe we can make it a bit more concrete, whether we are referring to more neural or related intelligence or anything that involves semantics. When we need to communicate, and then we have to rely on these meanings of words, and that is surely a higher level intelligence is a part of computational intelligence. But one of the things that surely is something physically intelligent stuff would need to face the computational intelligence is when it gets out of the lab and then in the real world, which is open-ended and needs to communicate or follow the social law, which is typically written in semantics. So they need to understand, for example, traffic rules. And traffic rules are written in semantics, and then interpretation of these semantics requires some sort of interpretation of some physical substances / robots. So that's actually one stage that embodied intelligence needs to leap and jump to the level that accommodates something that they haven't been implemented. So it's not a technologically plausible explanation, but theme-wise, that's really stands as a limit for the current embodied-oriented robots, in my view.
Yeah, thank you. Any others? I found that Hughen had a very nice slide contradicting the two different types of the intelligence. Do you have any ideas how you can really integrate?
Hi, Yuki. Actually, trying to embed in the the embodied intelligence, which in my slide I call it mechanical intelligence, with more high level and more complex computational intelligence is one of my future perspective. Currently, my thinking is that the mechanical intelligence mainly come from the material side. So we need to develop more like softer or more smarter materials that has many like embodied functionalities, such as like self-clearing, self-healing, like this kind of functions to build up the robot. But like if in the future, if we want the robot to really accomplish a very like intricate task, the high level, like more complex computational intelligence is very essential. So that is why that I try to like close the gap between them. And I found that one of the most important thing is I don't have off-the-shelf sensors and powerful actuators that can help me to run those algorithms in the software robot. So that is why I still starting from the fundamental components. I want the sensors to sense every, like our human beings, we can feel the touch from everywhere of our body. And we have hundreds of muscles that can generate the flexibility of the motions. I think those are the fundamental blocks to building a more powerful software robot with higher level of computational intelligence. That is basically my point of view.
Yeah, I think that if the embodiment becomes richer and richer, you also need a more richer the computational power.
Exactly. Yes.
Great. Thank you very much.
Thank you.
Amy, what do you think about the integration of the different layered intelligence? Can we just kind of go in a straightforward way, or do we have any like a new ideas or innovations to really integrate the different layers of the intelligence?
Sorry, are you talking to me or the other Amy?
Sorry, should I pronounce Amy? Or what
my name is, but it's fine. But yeah, so if I look into the surgical field, what's very important, of course, is safety. So you see a lot of like more autonomous system outside of that field. So inside the surgical field, there's still the surgeon that's usually in control. But I think if you look into the design of the devices, then what's also very important is maybe to look into more distributed control strategy. So like, for example, the octopus has the brain, but it also has sort of smaller brains inside the tentacles. So also think about how to maybe distribute the load over the whole system instead of just having like a centralized system. So I think combining that is part of it. Of course, there's much more to it than that, but that's also, I think, very interesting to look into in the future.
Yeah, that's a good idea to distribute the intelligence, the computational power as well into the embodied. Like, great, thanks. I now missed another Amy. I'm not sure whether she can be still online later. But we have their Gentian, their first keynote speaker. Would you like to join their discussion? What do you think about their integration of their embodied intelligence and computational intelligence?
I'm not an expert, I would say, exactly in like I would say the other way around. I'm partisan that we shouldn't split intelligence into these many categories, and we should really see everything as with an holistic perspective. And so I don't think there is an embodied intelligence if there is no computational intelligence, and the other way around as well.
Well, for example, if we look at the large language model, they don't utilize the embodiment.
I don't think it's intelligent. I don't believe they are intelligent.
So the intelligence must be grounded on the embodied experiences.
I think it has, yeah, it has to be somehow maybe grounded, but it's just that like, Yeah, maybe grounded. Yeah, I don't think about like pure intelligence from the brain or from something that has no interaction, that has no way to feel what is happening around it. So no connection with the environment, basically, and no connection with like contextual information. I mean, you can debate about like, a computer can still have some connection to some sensors and some information, but it has to have something someplace, and that's a body somehow.
Yeah, I completely agree with you that their embodiment is very important for the intelligence. But on the other hand, I also realize that, for example, if I ask some questions, something about the embodied related questions to the ChatGPT, for example, it answers as if it has an embodied experiences. Of course, it doesn't have,
obvious.
but then it can somehow, how can I say that, imitate or simulate or behave as if it has such an embodied experiences. That is the big challenge.
Because ChatGPT is basically trained on human data, and we have bodies, as long as I understand. They're not pure computational intelligence.
Yes.
And so all of the experience that is basing is knowledge and intelligence, it's based on our own grounded experience. And so it probably imagines that it has a body, or it had a body at some point. Yeah. And I really like the comments that Jeff is making, that it has like having a body is somehow poetic, which I love it. I think it also brings in some kind of like, uncertainties and like awkwardness maybe sometimes, or like a kind of like being a little bit gauche with your body. So you're making mistakes and you're not perfect. And I think this imperfection is also what makes us kind of intelligent, is we have to cope with imperfection. And maybe that's what is being intelligent, is being able to cope with what we cannot do and find other ways to do it.
I think that's a good point. I think we have to have the clearer definition of the intelligence, and also need to find out what is the limitation of the non-embodied intelligence or really embodied intelligence. Yeah, great. And I'd like to also point out the second question. So some of the speakers, except myself, all the speakers are working on the soft materials or soft robotics or the bio-inspired materials. And also the transformability is another important keyword in the embodied robotics. And then I'd like to, of course, I know the differences between such a soft robot or rigid robot and a transformable robot and non-transformable robot. Then in terms of the intelligence, the emergence of the intelligence, what do you think the advantages and also the challenges, difficulties of the soft robot or transformable robot? Do you have any like a clear definition between the soft robot or non-soft robot, transformable robot, non-transformable robot? What do you think the biggest challenges?
So I think if you look into the field of surgery, of course, it's very important to have a non-rigid body. And it's also like, of course, like the human body is always in movement. So your heart is beating. So having something that's flexible and can move with the body, but also something that can adjust its shape to the body. So every patient or every human is different. So having something that's be able to adjust to that is very important, also for safety concerns, of course. But sometimes the softness actually is not good, because, for example, if we're inside the heart and we have catheters, the blood is flowing, and what often happens is that the tip of the catheter just sort of like goes back and forth in the flow, which makes it for a doctor, for example, very difficult to perform surgery on a specific spot inside the heart. So then you want maybe that part of the device to become rigid, so that you can keep your position, or that you at least can move with the heart. So that's a little bit what happens in the surgical field.
I see. Now, especially the human body is very soft. So in order to, how can I say, access such a soft environment, like in the human body, it's very important to decide which part should be soft and which part should be rigid. Very interesting. So now we have Amy again. So
Yes,
what do you
sorry,
think?
I don't know if you
Oh.
are looking for me. My computer decided to restart. But anyway, so I wanted to. I mean, I think it's pretty clear what the benefit is for using soft materials. Like the other Amy mentioned, I think softness is a really good tool in terms of in the medical field, and because it's safe for interaction with human tissue. But I feel like the main challenge for softness or soft material is the repeatability in manufacturing. So if we were to make, I don't know, maybe even 10 different actuators, and can you make them perform exactly the same compared to actuators? So I think that's one of the main challenges that we all are experiencing, I think. So I think in order to have more development in soft robotics or utilizing softness, we also have to develop a manufacturing way to reliably and precisely control the soft material so that we can get the exact same performance when we make, many different devices. So the scaling, I think, could be a big thing for manufacturing.
Well, for example, there, of course, in order to make the more precise their action performances, then for me, the rigid the body would be easier, because it can repeat the same performances many times, and also they're more precisely can control. So then if you think about like an embodied intelligence, how the intelligence can be acquired through their soft body or soft materials, then for me, I can see the more challenges than the advantages if we think about the intelligence. What do you think? Do you think there are stronger advantages on the soft robotics in terms of their higher accuracy or higher intelligence?
In terms of intelligence, what is better for soft robotics? I think I need a little bit of time. Think about it. So if other people have thoughts, feel free to jump in.
Then can I ask the similar question to Shuhei? I think there transformability is another challenge for this kind of the embodied robotics. And then if the robot often change the shapes, it has to learn again, and then it has to also it cannot easily accumulate the acquired knowledges or experiences if the robot changes the shape so many times. So if you think about the intelligence, the advancement of the intelligence, what do you think the advantages and also the challenges or difficulties of the transformable robot?
Brad Nelson is giving us a plenary talk this afternoon, but when I was a student and taking his classes at ETH, he was, lectures were mainly focusing on how important shapes are or surfaces are rather than volumes are at a micro scale. So at a micro and smaller scales, the physical forces are more dominant by superficial factors rather than volumetric factors. So emphasis was more on the shape or more the rigidity of materials rather than the elasticity of materials. So, but if we look at the molecular level, even the structures may be rigid, the joints are flexible. So there are a certain numbers of degrees of freedoms embedded in these systems, and even the number may not be as many as soft materials. It does play important roles to perform something that we cannot easily achieve with rigid systems. So having said that, the intelligence that soft materials, if I look outside of the environment and then think of many situations, soft material surely gives flexibility in the space, but maybe in time as well. When one interacts with something soft, it also gives the time to respond, flexibility in time to respond. That enables a bit rich communication methods. For example, if two cars are passing each other, and then these cars are typically having rigid bodies, but if they are flexible, there would be another way of communicating, such as prioritizing one more easily. So it gives a flexibility in space, which we, in a way that we are not necessarily aware of. That's kind of my intuition, that how soft matter enables a bit more deep communication methods. This hard and soft comparison has always been central in many scenes. For example, Baymax, that was the movie Big Hero 6. Basically, there are two types of robots. One is soft, like a balloon, and the other one is a bad self-assembling, microbots, and they are fighting each other. And people project quite different aesthetics. Those who like microbots are not necessarily like balloon robots, and vice versa. So somehow when the macro meets micro, mechanics meets physics, or these two meets, that's an interface that we haven't probably yet explored so much. And that's a key to think of how to achieve a reliable, intelligent system that we yet don't have enough controllability. And that interface is something provided by the different interface between different scales or the different materials. So I'm not answering the question directly, but just my experiences and opinions.
Do you think that there are like intelligent behaviors which can be achieved by the transformable robot can be also achieved by other types of robot, like soft robots or any other different, using the different materials, different mechanics? Or the intelligence achieved by the transformable robot can be achieved only by the transformable robot?
Shape changes is an interesting keyword, but more probably fundamental aspect is how to distinguish self and the non-self, how to define, up to this border is me, and beyond that is not me, especially when the system can extend its body by adding other components that may result in the shape changing, but not limited to. And probably this aspect can also be seen in the soft robots whose volume changes. And then the addition of other components to the original body would surely require the system to override its definition of self. And at some point, when multi-components act in parallel, simultaneously sharing the same environment, this problem will be reasoned. So not transformable, or transformability is the keyword to discuss about intelligence, but more about setting the boundary. And then before stepping into a learning aspect, which system should we define as one system, and then the other will become an issue. That's my understanding.
I see. Thank you very much. I asked a similar question to Gentian as well, because the soft robotics is, of course, not the main target, but then their soft robotics or the soft bodies would also greatly impact their human-robot interactions. And then do you have any ideas or the directions that how you, or whether you are interested in utilizing such a soft robot as as a robot bodies, or you think that the rigid or mechanical, the robot is better for the human-robot interaction study?
Yeah, you're asking me a very difficult questions. Because I'm really from like you, from the rigid body community. And of course, we have at some point discussed about like doing more soft robots and because I'm interested also in dynamic interactions where we are like transferring force and contacts between ourselves and the robot and the environment and ourselves and the environment, soft robots might be very interesting. My experience, and that was one of the reasons why actually I came to Japan originally, is because I wanted to work on some kind of like soft polymer gel that could be used as like actuators for I thought they could be used for as actuators to replace like defective muscles and to build prosthetics. And then one of the things that I was very much disappointed was with very soft robots, not the one that we have seen and the one that Cecilia is working on and the one that we have seen today in many of the presentations, is that they are very slow. They are extremely slow. Their dynamics was very, very slow. And so they were absolutely not good enough to respond to like to do human robot interaction in a way that could be satisfying somehow. Of course, I'm talking about like almost 20 years ago, and things have changed around like over time, and we have now soft robots that are much faster and not just using like, you know, polymer gels or like these kind of like active materials. And so for human robot interaction, I think that there are some type of interactions where having a soft body can be very valuable. I don't think you want to hug a stone. I mean, or, you know, like, I think hugging something that is soft and tender is a lot more like healing. And so I think there are definitely situations where you think that having something soft could be useful. But soft means also maybe too complex to control in some sense. And so you will be able to create, and I think it relates to what Emmy was saying in the manufacturing aspect, but I would say that it's more in the control aspects. It's like, it's hard to get something that is reproducible somehow, but like, yeah, something that would be consistent, maybe. There will be more variability. And so some softness in the robot could be very valuable, but you need also some hardness. And continuously soft robots like the tentacles that we have seen and the trunks and these kind of robots, for human robot interaction, they might be also a little bit awkward or scary or like, yeah, weird, because we're not used to interact with these kind of like very soft and continuous systems. So soft, like chewy, or this kind of image, like, you know, like pillowy, maybe, but continuously soft that has this like weird, like, it's not weird, but it's just like different way of moving, might be a little bit startling for many at first. So maybe we should interact more with animals and entities that have like these continuous way of moving, and maybe then we'll get more used to having robots that can do that. But for human robot interaction, I think fully soft is probably not the way we want to go. That's my opinion, but I think it's worth trying. So it could be fun. Maybe we can find very new ways of interacting. We could, like, you know, have robots like moving around us and embracing us in ways that like we can't think about. It could be fun. That could be very very good as well. Yeah.
Yeah, thank you. I think we could learn there are many ideas how we can inspired by like an animal, like for example, Amy showed a very nice example of the gecko inspired architectures. I'm very much impressed by that. how you can really mechanically reproduce this gecko mechanism, and then we can integrate many different types of their bio-inspired mechanism into our robotic system. But we have to carefully think about where to develop what and where and what is the combination is very important to think about. So I think that we have only the 6 minutes left, and then so I asked many questions to all of you, and then maybe you may also have some questions to ask the other speakers. So do you have any questions or comments to the other speakers' research, or any additional discussion point?
So I have one question maybe, and also because we haven't heard Hui-chan too much, and I'd love to hear her perspective. I think we were talking about like the body in terms of like maybe degrees of freedom, but how would that pair with sensing? And how would you imagine, like, because basically increasing the number of degrees of freedom definitely needs better sensing and better understanding about the surrounding world, and also what Shuhei mentioned about like yourself and the rest of the world. So maybe you have like a comment on this, and you could like talk about that from your perspective.
Exactly. So Wenqi, I actually have one comment about the soft gels you mentioned about 20 years ago. So actually today we could build very fast soft artificial muscles. So our muscles can go to a bandwidth of about 200 hertz or 300 hertz. They respond in milliseconds, and they can have a power density that is similar to the level of normal electromagnetic motors. That is about the artificial muscle or actuators advances in recent years. And in terms of the soft and rigid degree of freedom question, so for most of the robots that we built in our lab and my previous lab at Cornell and Harvard, we found that none of the robot is purely soft. Almost none of them is purely soft. We actually strategically make some places, make most of the places rigid, and still like remain some places compliant to adapt to terrains or adapted to the object we are building. So yes, I think that the infinite degree of freedom definitely put a lot of challenge in control and also sensing. So the last work that I showed in my presentation is showing that we're using a optic fiber to reconstruct the continuous shape of a structure. That one, we actually don't use degree of freedom to describe it as a discrete system. Instead, we use the Coulthard rod theory to describe this continuous shape. In that way, we can get what is the interaction force with the environment and its own like state quite well. But how to control this very complex shape is another very challenging problem. And I think the other Amy who was doing surgical robots, she might have more insights about this point of view. Yes.
Great, thank you. It's very nice to know that there are the soft actuators also get better and better. So we can now really integrate that's such a mechanism. So unfortunately, it's already the time to close. And then if you have any very last message to convey to the audiences, can you give just one word from each speaker? Shuhei, would you like to say one word?
I'm not prepared, but actually I wanted to ask Yuki about your perception on the difference between computational intelligence and embodied intelligence.
Well, so in our experiment, we use a very rigid body But then we really show that the embodiment is very important for first the obtaining the merge model, the associated sensory signal, because the neuroscience theory is often focusing on the single modality, like only the vision, only audios, and then talk about, okay, the visual processing, the audio processing. But our embodiment is really providing the rich experiences, integrating the merge model signals together. And we are currently focusing not only on the vision, audio, or proprioception, but also the interoceptive signal, which is a sense of the internal body, like a heartbeat signal or breathing. Such an internal body state also plays an important role in our cognitions. So we really want to go to a little bit more to the soft robotics side to show that how their internal state of their body would also impact on our intelligence. And we hope that we can also develop the computational model for such an embodied their intelligence, integrating their computational parts and then the embodied side.
That sounds interesting. Yeah, proprioceptive and also reconfigurable systems needs to know its own current state. So I see some commonality in here. Thank you.
Thank you very much. So unfortunately, it's already time to close. So I'd like to thank again all the speakers and also the great discussions. Thank you so much.
Yeah. So thank you.
Thank you.
Yeah.
Bye.
Take over from here. Yeah. Thanks a lot for all speakers and all attendees for coming for the morning